Ah, snowflakes. The pretty ice flowers that fall down from the sky. They make for some great paper crafts. But they're also really weird, because no two snowflakes are going to be the same. Why? Let's look at the life cycle of a snowflake. Let's go! So most snowflakes start their life high up in the atmosphere, where there's a mixture of gases, water vapor, and dust particles. For now, we're going to focus on the water molecules and the dust particles. At higher altitudes, the temperature is very cold, so then the water vapor freezes around our specks of dust. This causes ice crystals to grow around a center, and as this travels through the atmosphere, more water molecules around it start to accumulate, and this leads to the growth of our snowflake. But to understand why our snowflakes are hexagonal, we need to take a closer look at water, or H2O. Remember that in one molecule, we have one oxygen bonded to two hydrogens. If we put 6 of these molecules together, you'll see that they come together into this hexagon. And if we add many more of these, then we start getting a honeycomb lattice. It's quite beautiful, and it explains why snowflakes aren't other shapes, like squares, for example. Now that we have seen the general structure of a snowflake, we can start to understand how its shape changes as it grows. So in this movie, you can tell that at first there is an even growth of a hexagonal plate before it branches out like a tree. These branches are known as dendrites, and the environment that the snowflake is in can decide whether it will grow as plates or as dendrites. For example, if its environment has low humidity, or if the surrounding air is very cold, then the snowflake will cool slowly and grow as flat hexagon plates. But if the environment has high humidity or hot air, then the snowflake must cool quickly, and this leads to the formation of those dendrites. So, every snowflake shows a timeline of its environment, from its start at high altitudes and colder temperatures, to lower altitudes and hotter temperatures. So we know that our snowflakes start up here and end up down here, but they all take different paths on the way down. Just look at what happens when I drop them. As you can see, they had different routes. And remember that the atmosphere is not the same everywhere. You can have pockets of hot air up here, colder up here, maybe this area has higher moisture, a gust of wind that way. And because every snowflake shows us a snapshot in time of its environment, we can see that different paths are going to lead to different patterns. And this leads to a beautiful uniqueness, but still symmetry that comes from the bonding between water molecules. We can't just stop at plates and dendrites though. Snowflake scientists such as Nakaya have found many different types of structures that you can have, like needles, columns, thin and solid plates happening at different humidities and temperatures. This shows that there's a wide range of things that can happen with snowflakes, and it's quite a fascinating field. So now the next time you see snowflakes, think about the symmetry and randomness in nature that leads to quite a beautiful world around us. Thank you for watching.